It's
Yeah,
a
I don't
special
know.
case of 38, right? But why?
Yeah,
So
it
why
seems
prove
like
it?
he's stressing a little bit about the same base and equal basis. He wants to separate. This is not the first time this has been separated as two different propositions, right?
But it's fine, I guess, in 35 and 36 because that
Right.
was actually a generalization, right?
Yeah, yeah, it
And
is.
36 uses 35, but there's actually no point in proving proposition 37. It's a special case of 38. It uses a weaker hypothesis, so I suppose there's some like economy or something in using a weaker
Right.
hypothesis, but it's really a bit strange, yeah. But anyway, we
Maybe,
might as well.
maybe possible that Euclid forgot about 37.
he was writing the book 1 week at a time, like we're presenting it, and he just forgot
Yeah,
it.
I mean, it could be that he just took a sabbatical, like went drinking or something, came back. Oh, well, what was I up to? I mean, we don't know,
That,
right?
that's the most likely explanation. Okay, you should proceed with 38, I guess.
Cool. All right, let's start with 38. So, as I said earlier, I'm going to do 38 and 40 consecutively. Thanks. And because they're converses of each other, and as Dan was saying, 38 is essentially a slightly more generous form of 37. So I'm going to try and be quick here. We'll see how we go. So triangles with equal bases, bases between the same parallel lines, lines have equal area. And the only difference here is that in the previous proposition, the hypotheses were the same base instead rather than equal bases as we have here.
Ken, I think you haven't attached a speaker yet, just for
Oh, sorry about that.
when
Let's
you
do
move
that.
boards. Right now, it doesn't matter much.
Sounds good. I think I'll do that now. Cool. Okay, so back to the diagram. We're going to have two parallel lines like this, and we're going to draw some triangles between them, like so. And of course, I'm going to try and make them slightly skewed. And the hypotheses, well, let's label them first. This is B, A, B, C. And the other triangle is D, E, F. Right. And we're going to assume that BC is equal to EF, and also assume that these lines are parallel. So yeah, so let AD and BEF be parallel lines, and C and E be points on BF such that BC is equal to EF. And I'm just going to assume BC is equal to EF. So these two are meant to be equal. Then the conclusion or the claim is that ABC and DEF have equal areas. Okay, so I'll go to the next board for proof. So proof. So we're going to construct a line through B parallel to AC. So I might have to return to the previous diagram to make this construction. So construct a line through B parallel to AC. So this is by proposition 31. Let's go back and make this construction. So we're going to construct a line through B parallel to AC. So it's going to look like this. And these two are now going to be parallel. I'm going to construct another line. This is something that I haven't written down, but I'll do. Construct HF. I'm going to construct it like, wait, sorry, that's not quite what I wanted. So I think maybe I've labeled it in a funny way. D, E, F. I meant to construct H.
It'll be okay if you have H
Oh,
going on
sorry. Yeah, I'm
parallel to
just
D,
trying
just off
to.
to the right hand side.
Yeah, I'm just trying to stay within the confines of the board. Maybe it's okay. Yeah. Uh, I was trying to skew this, but maybe I was too ambitious. So okay, so now these two lines are parallel. Mark them here, and I also need to label the points of intersection of these new parallel lines with the top line, and they're going to be G and H. Okay, so these are analogous constructions, and so just going to go similarly. Construct HF. Maybe I should say through be parallel to AC, intersecting AT. What I didn't say here was intersecting AC, AD at G. Basically what's in the diagram, but just kind of written down in words. Okay, then we have some parallelograms because these are now intersections of pairs of parallel lines, so we know straight off that they're parallelograms. So the first parallelogram, GBCA, and the second parallelogram, DEFH, are parallelograms firstly, and moreover with equal areas, because they are parallelograms between two parallel lines with equal basis areas. Right, and we know this because of proposition 36. So the parallelograms equal areas since they have equal basis between the same set of parallel lines. And yeah, so that's proposition 36. And I think the only thing we need to do now is that the diagonals of these parallelograms, these diagonals are the original sides of the triangles that we were trying to consider. So AB and DF, right? So since diagonals, I guess AB corresponding to the first parallelogram and DF cut parallelograms. These parallelograms are, as we said, GP, CA, and DEFH in half. Then the triangles that we were trying to look at before, which ABC, DEF, have equal areas. And hidden in this is something that we mentioned earlier, is that half of equal things are equal. I think Dan made a comment about this last time. We already used something like this to prove a previous proposition. Now, what I'm missing here is actually the reference to the cutting parallelograms in half. I missed it in my notes. Dan, do you remember what proposition that was? Or was it just 36?
No, it's not 36, it's 34.
Cool, thanks.
You mean the fact that the diameter bisects the areas, right?
Yeah, that's right.
It's 34, yeah.
Thanks. Yeah, I didn't have the reference there. Cool. So that's it. So we've shown that these triangles are actually halves of two parallelograms with equal areas. So therefore, they must have equal areas because of the half of the same thing. Cool. So any questions?
I think it's one of this series of arguments is one of the places where, what we're about to prove regarding triangles and so on, and this proposition, it goes via the parallelograms in a way that isn't obvious if you just set out to prove 38, right? If I just gave you 38 to prove, it's not so obvious that you should introduce the parallelograms, right? So it's quite interesting to see the it's a neat idea.
Yeah, I guess plane geometry is like that, right? If you make the right construction, sometimes you can do cool things. I mean, especially if you're not allowed to introduce coordinates and just bash things through, right?
Mm.
Okay, so let's move over here and use the new board. I'll wait for the orb to settle in. Okay, so proposition 40 is the converse to 38. This is a converse to proposition 38. My handwriting is deteriorating a little bit. I'll try and make it readable. Triangles with equal areas. Yeah, as I was saying. So this was the conclusion of the last proposition. We proved that certain triangles have equal areas, and start with this as a hypothesis, and equal bases along a straight line lie between parallel lines. And so we're going to try and prove that some lines that's constructed from two triangles are indeed parallel, given the fact that they have equal areas. So we're going to start with, I'm actually going to draw two diagrams here because as I was doing this, I noticed that I was being, well, this has kind of happened before, but let me see if I can do this nicely. That sometimes I'm going to draw the first one like this. I'm going to draw the second diagram like this. And slightly down like that. I'm going to draw some triangles here, and they're going to be triangles with equal bases. I'm going to go back like this. I'm going to draw another one like this. And here, and these are going to be the same labeled diagrams. Diagrams are the same labels, just slightly different lines here. So it'll be B, C, E, A and D. Is a B, C, E, A and D. And yes, the reason why I'm doing this is that what I'm actually going to do now is I'm going to make a construction. So I'm going to try and prove that BE is parallel to AD, right? So I'll write the text for this maybe a little bit later on. But the first construction in the proof is that we want to try and construct a line through A parallel to BE. So I'm going to make the construction here, and I forgot to use the line tool again. I've got this wonky line here. Let me just, all right, that's good enough. Yeah, so I'm going to try and draw a line here that's parallel to BE and connects up these two. These are parallel. And in the other diagram, I'm going to extend this a little bit. I'm going to draw a line parallel to A to BE through A like this. Oh, I wanted a different color. Okay, let's see. I'm going to do a line here like this, and drag it down to here like this. And these two are supposed to be parallel. Okay, so this diagram is these diagrams are similar to the ones before. So I'm gonna go to the next board with the proof. So and also maybe the statement first, right? So I guess the claim is that if BAC, so ABC, and DCE have equal areas, you know, and also that AD is parallel to BE. Wait, sorry, that's not what I wanted to say. That's the conclusion. If they have equal areas, and I guess BC and CE are equal, then AD is parallel to BE. And the way we're going to prove this is, as I've already kind of indicated, that we're going to suppose that this is not true and construct a line through A parallel to BE, which is the red line that constructed on the previous diagram, the red kind of more or less horizontal line. I'm going to join that line, the intersection of that line with CE with, call it F, and join that with E. So I'm going to suppose not, right? So we're going to construct a line through A parallel to BE. And we know we can do that from a previous proposition 31, right? That allows us to construct lines parallel to a given line through some other point. So we construct this line parallel to BE and intersecting CD at F. And I'm going to join up F and E as shown in the diagram. So then, by the previous proposition 38, we know that the triangles ABC and FCE, so FCE is a new triangle that we formed using the newly constructed line FE, right? So that new triangle has the same area as the original triangle ABC. So then by 38, the triangles ABC and FCE, that's the new triangle, have equal areas. Yeah, because they have equal basis between parallel lines. So I find it interesting that we're proving the converse, kind of using the original proposition by contradiction. I guess this is a common, well, not a common, this is a strategy that's employed by Euclid in various places. I think we've already seen this somewhere else. I don't remember exactly where though. So yeah, so the
Maybe
last thing
you want to mark F on the original diagram.
Oh yeah, thanks. I think that's something that I neglected to do. So F is this this point here. Sorry about the F is the red point. Thanks. Very close to D. Maybe I should have.
I think it's fine. I think it was fine even without labeling it, but just
Cool.
since we're
Thanks. I guess for completeness, right, we should have the labels. Okay, so they have equal areas, but the contradiction is that ABC and DCE and DCE, right, have the same area by hypothesis, and so DCE and FCE have the same areas, right? Maybe this is probably getting too laborious. I'll just say, so FCE, DCE have the same areas. This is a contradiction because FCE, so the reason why I drew two diagrams is because the first time I did this, I kind of said, oh yeah, FCE is part of DCE. I'm like, well, hang on, it depends on how you draw the diagram, right? So the contradiction because either right, the DCE is part of FCE, all right, or FCE is part of DCE, and you know, when something is a part of something else, a proper subset, I guess, as we would say in modern language, they can't be equal. So that's it.
Yeah, I think it's only one of the cases is in the book, right?
Yeah, I mean, but the language they use in the book isn't exactly how I said it, so maybe it's fine. The diagram certainly is just the first diagram, but He
Right.
doesn't say one is part of his as a greater to the lesser, which I never, up to now, I have no idea what that means. I mean, I guess it
Yeah,
means what I said. Maybe that's a neat way of covering both cases, right? I don't know.
maybe. All right, cool. You want to detach? I'll attach a speaker.
Yep.
All right, so I think we don't have to do 38, right? So Ken just did, 39. Ken just did 38 and 40. Notice that 40 only used 38, didn't use 39. And proposition 39 is a special case of proposition 40. So 39 says equal triangles which are on the same base and on the same side are also in the same parallels. So it's a special case of being on equal bases, which is what Ken just did. So proposition 39 is an immediate consequence of proposition 40. So I'm now doing proposition 41.
Cool.
So proposition 41 says if a parallelogram has the same base with a triangle, and they're in the same parallels, so that's the following situation. So let's first draw the parallelogram. That'll be ABCD. And then we have a triangle with the same base. So let's make that EBC. Then the parallelogram has double the area of the triangle. So what the book actually says is that the parallelogram is double of the triangle. That could be interpreted two ways, right? It could either mean that the parallelogram can be constructed by taking two copies of the triangle reflected across some edge and sticking them together, or it could mean that the areas have the relationship of being double. Those aren't the same statement. So maybe I'll just leave it as I already gave away the answer, but we could have it remain a mystery for the duration of the proof which one is true and see. All right, so I already constructed the parallelogram and the triangle. The construction is as follows. So let AC be joined. So that's bisecting the parallelogram. Then the triangle ABC is equal. Well, let's leave a blank here. It's equal to the triangle EBC. Because they have the same base. And are in the same parallels. This is proposition 37. Well, 37 actually says they have the same area, right? So that's what goes into that bracket there. Equal in area. And now we're basically done, right? But the area of ABCD is by, what's this, 34? Double that of that triangle. And since the area of that triangle is the same as the area of EBC, the claim follows. Right, so that was kind of easy.
Cool, yeah, that was pretty short.
Yeah, I guess we probably, 42 is a bit longer, so yeah, I think we should leave it to next time. It might almost fit, but I think it's not worth rushing it since it's a bit more involved.
Cool.
Yeah, thanks a lot, Ken.
Nice.